Hello everyone, this is GATE Electrical 2024 question number 41. For a two-phase network, the phase voltages VP and VQ are to be expressed in terms of sequence voltages in V alpha and V beta as given, and the matrix S is being asked. So 4 options are given. For references, you can refer to lecture 3 Fault Analysis Review Sequence Components by Professor A.K. Pradhan, Department of Electrical Engineering, IIT Kharagpur, and you can also refer to this book on the 2-phase or 4-phase or 3-phase symmetrical components by going to this link, which analyzes the symmetrical components in more details for multi-phase networks. So coming to the concept, for a 2-phase network, let's say we are having VA and VB, some arbitrary voltages, 2 phases are there, and there is some phase difference. So we can actually decompose. So VA is not equal to VB. They are not symmetrical, right? They may be having some unbalance or some phase shift also. So it can be broken down into 2 components, where we can write it as VA0 VB0 plus something where we can write it as VA1 and VB1. So 0 degree and 180 degree phase shift, 2 components. We can build symmetrical components. One set of symmetrical components are having no phase shift, that is they are co-phasor, and one set of symmetrical components are having 180 degree phase shift among them. So sum of these two, and obviously VA0 equal to VB0 and VA1 equal to minus VB1. So if you sum them, you can just replicate this VA and VB phasors. So now coming to the solution, so I can write VA as sum of VA0 and VA1, and VB as sum of VB0 and VB1. So again I can write VB as VB0 and VA0 are same, and VB1 and VA1 are related by 180 degree difference. So VB can be written as VA0 minus VA1, and similarly this can also be broken down as VB0 plus minus VB1. So if I write down VA and VB, you can write it as 1 1 1 minus 1, and here you are getting VA0 and VA1. These are the sequence components. These are the real signals, the 2-phase components. So this is possible. Similarly, you can write it as VAVB equal to 1 minus 1 and 1 1, VB0 and VB1. There are also another set of sequence components. So these 2 vectors are possible. So we get one of the vectors, and as you can understand, the transpose of this vector is also possible, right? So this is one possibility, this is another possibility, and their transposes are also possible, because we can just flip VA1 and VA0, right, and write like that, so without loss of generality. So these 2 are possible. Option B and D are the correct options. Thank you.